All right, this is a very exciting talk for me. First of all, because it's great for me seeing all the people I've worked with for almost 2 years now in person for the first time. And also because that the product we're gonna demo today is the first time we ever demoed it, we ever showed it, even it's the first time for some team members if they are watching the live stream to see it working. And so it's just super exciting. I hope really everything works well. Maybe a bit of background information about myself. I'm Fabian, I'm the CEO and co-founder of KYVE Network. We got started in the Arweave ecosystem in, I think it was late 2019, early 2020. No, sorry, actually mid 2020 is when I reached out to Sam and we connected a lot about a product called Verify, which was my first project in the Arweave space. Maybe some people are still familiar with it. It is like an on-chain, kind of like KYC network analytics tool where you could really see if an address is owned by a human or if it's maybe machinely operated. And then from there on, we went into kind of like developing KYVE. It was a grant first, but we'll now dive deep into what KYVE is and how everything got started. So for today's agenda, we're just quickly gonna talk about KYVE, the new data pipeline, then the big demo. Everything is fully live, and so I'm very, very nervous for that. And then some quick roadmap about the next kind of things that are happening for us and that's gonna be updated. And basically, the big problem that KYVE is solving is working with data in the crypto space, right? Because Web 2 right now is not made to communicate with Web 3. Web 3 is not made to communicate with Web 2, and Web 3 is not even made to communicate with Web 3, right? And so we really see that accessing all these large amounts of data in other networks, it's getting very time consuming. If we talk about Ethereum and maybe syncing a node, this can take up to weeks or months, right? We see Solana always having some trouble with syncing their data and kind of managing that because, well, you can optimize for speed, right? Then you're very fast, but then you can't store much data. Or you optimize for storage, then you can be very fast. You can't be very fast. So it's kind of like really basically hard for developers working with a solution where they want to deliver a good UX to a user, which is obviously fast, right? But of course, I also want them to be able to work with all the data, and same for developers. And so basically, then what came up were those indexing solutions, right? It's like where you index data, you use the graph, for example, that basically creates a local copy of Ethereum data into their nodes, and then they make this public. But actually then with the whole Oracle system and indexing system, you run into the risk of having invalid or out-of-date data. And this is actually very, very, very crucial, and we see actually hacks happening on the Oracle networks quite frequently in the last few months, where you have the problem that you have some data that is maybe not verified, not validated, maybe even corrupt, coming into this completely trustless system as a blockchain, and then once a hacker has control over the Oracle, right, he's then able to drain the whole application. Just think about an AMM that would use some external pricing, and someone is able to modify the external pricing source, and then, right, you can drain everything. And so this is why it's very, very important to make sure that working with data in this space stays very trustless, right, or stays fully trustless and fully decentralized. Otherwise, we are really building like a 2008 financial crisis type of style on the blockchain, where we keep adding insecure infrastructure on top of each other, and then it's just a matter of time, right, until some of these things collapse, and then it's like the cascading effect, right? Then the whole network basically just goes down. And then we have a third problem, which is that you have different data access requirements for different use cases, right? We see the graph, which is awesome for GraphQL access on EVM. We see dual analytics for SQL access on blockchain data. But I mean, for every developer here, you guys know everyone uses their own tech stack. There's like stuff that's more suitable for certain use cases, right? GraphQL is great if you have like, want to do very deep queries. SQL is great for more like analytic purposes. And so this is really the problem, because otherwise what we're gonna do is we're just replicating data into all these like centralized data warehouses and kind of like distributing the problem and saying, well, there might be more stuff going wrong from like application to application, but we need this central layer, right, of trust and like working with data there to make sure it's always valid. And so KYVE is a fully decentralized data lake that enables developers to build scalable and data-intensive applications by providing easy access. And basically the way it works is you have any blockchain or any data source that goes into the KYVE network. KYVE then stores and validates the data, right? And then basically stores a proof and makes this available to the users on-chain. And how this works in practice, our first partner we worked with was Polkadot. And the way it works there is you have your own, it's called a runtime, a pool, where you define how you relay your data. So for example, you would connect to a Polkadot node, pull down block number 5, then relay this to Arweave. And then the uploading node would propose this data to the other nodes and say, hey, I've uploaded this piece of data, and of course I'm confident that if I've uploaded this right, please challenge me. So all the other nodes download the data, they run a validation function, and if the data matches, they say, well, that's perfect, we're gonna vote in favor. And if it doesn't match, they vote against it. And then basically a piece of data can be, well, valid, right, invalid, or can be dropped if there's no consensus that is reached. This sometimes happens if you're working with undeterministic data, where you're not really sure if it's like truly false, truly invalid. So that's kind of like when a piece of data gets dropped. And then of course the nodes that voted on the rights, on the majority side, get the payout. So everyone is incentivized via the token model to vote in behavior of the network. We have a lot of active integrations right now, focusing a lot about archiving use cases for blockchains. Why especially archiving use cases? Well, because you see the problem happening, especially on EVM, where actually the data is, there is no incentive for nodes to store the data, right? EVM is highly incentivized on block production, because you get money for producing a block and finding it, but no node is incentivized to keep the data around. So if you would be a node operator, what would be the next normal thing for you to do? Well, you would start, right, getting away from a full node to basically just a normal node, because you make more profit, right? You have to maintain all this data infrastructure, the databases, the people that manage that, and this all costs you money, but you're not only getting money for producing the blocks. So what could happen in the future is actually leading to data centralization on the availability part. Solana is also, again, a very good use case of that, where actually the data production on Solana is highly decentralized, but the data availability, especially to the old data, is super rare. Basically just only the, like Solana, I know the Solana Foundation is maintaining one full node that's free to access. And for all the others, you have to go to companies like Coinbase Cloud or whatever, and then purchase a full node there if you're a developer to access this. Although the Solana data is a public good, right? It can be accessed, it should be being able to access from everywhere. And so we're really running into this interesting problem where how do we keep data around? This is actually why we've, well, stick to Arweave as our permanent storage solution, because they have created the incentive for storing the data. So it's kind of a bit as Jakub talked about the smart contracts, where you start to separate, right, the production from the storage, and it's kind of like exactly what KYVE does for other applications. Another big use case we actually have is also getting Web 2 data into Web 3, but we're talking about big data, basically data sets. So one very interesting use case we have is storing weather data, where you have all these sensors all around the world that basically create IoT data, and they say, well, actually, how do we make this data available in Web 3? And then KYVE is a perfect use case, where basically KYVE decentralizes the data via a runtime for you. I'm going to dive deeper into this in the demo, and then makes it accessible there. Financial data streams is also a very big use case of it, but as I said, we're mainly focused right now on the archival use case. So now we jump into the exciting part of this demo, which is the launch of our new side product called KYVE's Data Pipeline. It is a no-code solution that allows you to get all of the data that is stored in KYVE into any, literally almost any data source you want with zero code. We're using a framework called Airbyte for that. And why is there a need for that? The problem that we see is that developers want to have the flexibility to work with the data stacks that they are used to, and it makes sense in their use case, right? When do I use maybe like Snowflake over a MySQL database? When might I use S3 over MongoDB, right? There are multiple reasons for multiple applications to really create these kind of like needs, and still, what everyone has to keep in mind, all the Web3 nodes are still using the Web2 databases, right, for managing that. So we thought, well, can we create a product that allows the developer, without having to code anything, to get access to KYVE data into wherever stack they want to work with? And basically the way it works, it's an ELT pipeline. For people that are not familiar what ELT means, it means extract, load, transform. So we're extracting the stored data from KYVE, loading it into your chosen destination, and then it's up to the developer if they want to, right? We're going to do this in the demo, where the transform script that makes it then even easier to work with your data. Before I start the demo, maybe a quick question. Who of you is familiar with MongoDB? Well, that's almost everyone. That's perfect. That's great, because the demo is going to be getting the data into a MongoDB database and transforming it there. So let's get to the exciting part. That's the second screen. Let me try to mirror that real quick. There we go. Yeah, amazing. Perfect. So the KYVE data pipeline is right now released for our beta network. The beta network is going to be merged into our public testnet Corelia within the next days. And then actually we're also approaching the code freeze on that, so it's a super exciting time for us to be in right now. Don't worry, the overview here is empty. On the right app for the Corelia network, of course, it's filled. So here we have those storage pools. So you can see here in our beta network, we're storing the Moonbeam data, Celo data, Bitcoin data, and you can see here we have these runtimes. And so, of course, all EVM compatible chains we can archive with an EVM runtime. You see the delegation and the staking. I didn't went too much into the security part yet. I'm happy to add a few comments on that later if you guys are interested, but this is some demo use cases we're gonna cover. And we click on a pool, you can of course also see the indexing progress. So Moonbeam is almost fully indexed. Bitcoin, we're catching up, but if you go to the app, we have some already running pools that we can see that we have archived them completely. So now heading into the Moonbeam pool, you can see here the current bundle progress. So one bundle always takes 2 minutes or up to 2 minutes to be created for the nodes to kind of find consensus up. Just got a vote in, let's check what it is. Perfect. It's an abstain. That usually means that something is going wrong and the nodes don't have the data yet. Keep in mind it's a new bundle and Arweave has quite a long time to finalization. So of course it takes some time and this will update live and hopefully we get to see a valid bundle being created. You can add any type of metadata you want to your bundle into your runtime. The runtime simply is two functions. One is an upload byte function and one is a validate function. Upload byte function returns bytes. So if you're a developer, you can put in whatever you want. Here it's the JSON file of the block we are storing. And the validate function has to return true or false. So however you guys come to a result on how you find one piece of data valid, it's up to you. You can code it. The way it's implemented right now, mostly, it's a hash comparison. So we check, is the uploaded hash the same as our local hash? And if so, we vote true. If we go into the bundle section here, it's not takes a few seconds to load usually, you will see the bundle ID and the storage ID coming up. The bundle ID is the KYVE internal ID to retrieve it from the chain. And the storage ID is the ID of this bundle on Arweave. You even see a status, which is usually valid, invalid, or dropped, as I said before. And of course, the chain over time only keeps track of all valid records. So you can basically just scrape through all of them to get them into your system. Perfect, there we go. So you can see here a lot of things got dropped. This usually means that some endpoint is down or something like that, but we also see some valid endpoints being produced here. And if we now would click on the download of this Arweave ID, we just download some gzipped, compressed data, nothing exciting to show, but this is the data that lives on Arweave. And the way to access this in the most simple way is through our REST API. Our REST API, you can see we're requesting API beta KYVE network /finalized bundles 0. 0 is the pool ID. That's actually very important for the demo coming up. Here you can see pool ID 0, and then Avalanche, for example, has pool ID 1. So /pool ID. And then you see the pool ID we're storing it, the ID of the bundle, which is just a growing number, the storage ID, the upload, or whatever, a lot of metadata around this, and it's a paginated API. If you scroll all the way to the bottom. There you go. You get your normal next key, your page size, and you would just iterate through this. You can then download the data from Arweave. You would unzip it, and then you would unbundle it. And then you can compare if the data hashes match. So basically you would, you do the hash comparison first, and then you do all the unbundling. So while downloading it, you check that you're not talking to a corrupted node, so you get the right results for the data you have locally, which from the ones you got from Arweave and from the node. As you can see, it's quite an intense way of requesting the data, so this is why we came up with the ETL pipeline. The ETL pipeline lives in a repository that's available on our GitHub. There we go. And it uses Docker Compose. So this is the source we wrote here. You can see the code is big enough. Can I get some thumbs up if you guys can see it? I get perfect, amazing. So you can see here we're doing some simple checks on the KYVE source, which is, well, we're requesting the pool ID, we're requesting this endpoint I just described, and then we also check, which is very important, if it's a valid runtime. So you can see right now, we only have the KYVE EVM as a valid runtime. So in case it's incorrect, right, we return the error runtime. It's not supported. And if we get any other error right now, we're just printing the JSON file. And now the magic happens is we just write docker compose up. And what's happening now is now Airbyte is starting its backend system. It exposes a UI where basically you can create your connection. And it also sets up like scheduling services, so you can set the stream to run every hour, however you want. You can host this in your local environment. That was very important for us, for everything to stay truly decentralized, right? You want to compile this and build this on your own machine. As you could see, there was the localhost 8000 popping up, which means it is online. So if we go here now, reload. Amazing. So see, this now runs on localhost. This is already pre-filled because it's for the demo, but no worries, we're going to set it up from scratch. Airbyte works with sources and destinations. The source, obviously, in this case, is your KYVE pool from which you want to fetch the data, and the destination is whatever you want. So let's maybe start setting up like a destination. You can see I already pre-created the MongoDB destination, and we are going to use in this demo a local SQLite database, a local JSON file if you just want to have it for some reasons. If you want to create a new destination, it's super easy. Click on it, and here you can see everything that Airbyte supports. So we're talking from S3 to Snowflake, Redshift. It's an insanely huge list. So there should be, for any developer in here, should find their favorite kind of like database to work with on that purpose. Let's say we want to use Postgres. You would put in your host, your DB name, whatever. I think everyone who works with Postgres is familiar with that. The data is schematized by Airbyte automatically, meaning you don't have to worry about setting that up. You click on run, and you're good to go. We now use the MongoDB destination that I've already set up. And see there are some like demo settings here, and well, here's all that stuff to set it up. For the source, we can just create a new source. We use, I hope I get the right one. No, this is the with the Pokemon name. There we go. Perfect. So you see this is the KYVE, that's our custom source we created. We can give it a name. Let's say we want to archive Moonbeam. Add Arweave demo. And the pool ID. And as you can remember, Moonbeam had the pool ID 0, and we implemented this check to check if the runtime is supported. If we use in some incorrect runtime like 2, which should be cello, you can now see Airbyte is now checking, and you can see, well, it's an error, right? Error, runtime, cello is not supported, EVM is supported. So 0 is the pool ID of Moonbeam. Let's double check this very quick. Moonbeam, pool ID 0, 0, setup source. And now all connection tests passed, meaning we have successfully created this source. Next up is create a connection. We can do it through here, but I'll show you the real process. Set up a new connection. The source is Moonbeam at Arweave Demo. And we use this, oops, I should look at my screen maybe, that's easier. And then the destination, which is the MongoDB that we have configured. And it just does 2 more connection checks, and here we are. So now basically we can give this a name, which is Arweave Demo, and then we do Moonbeam to MongoDB. You can set up custom replication frequencies. So if you want your data warehouse to be up to date every minute, you just put, well, the replication frequency to every minute, every hour, whatever. For the demo, we just put it to manual, because it will take some time anyway, so we'll not see the full syncing process happening. Here down, you can see that the stream source is an EVM, it's EVM data. And the mode is either full refresh, which would mean that we would set up our new data warehouse every time we refresh, not what we want. We, of course, want incremental. Incremental means we only take the new data in a period and add this to our data warehouse. We set up the connection, and we could start sync now. And the job will start in the background. Airbyte will handle all of this. And this would now, in reality, take probably 20 minutes because it's the first run until everything is in your warehouse. Otherwise, it gets updated over time. So I'm just going to quickly cancel this. And then, let's say this has fully passed. We then just log into our MongoDB database. Everyone here familiar also with the MongoDB Compass? Yeah, I see some nodding. Amazing. So basically, we created this Airbyte test collection, and here's our raw EVM data. You would now see, that doesn't look like EVM to me. You see here, it's like a lot of loaded data from Airbyte. So the E step was the extract step. Here's the load step. And in Airbyte data, you now see what looks way more familiar probably to most of you, which is an EVM block. And in the EVM block, you see, well, the block number, the height, whatever, and you see the transactions in here. right, with the transactions here, and so on. But of course, now you think to yourself, actually, how do I query this now nicely? Because you would need to like query Airbyte data in this and that, and it gets all messy. So this is where the transformations step comes in. For the transformations step, we just spin up our own script, which is a couple lines of code. We make this very small. We're just connecting to both databases. First of all, the Airbyte test, where you want to source the data from, pull it into the Moonbeam new database. We set up our model where we say, well, the raw EVM data has this like weird Airbyte data field, which is a dict. And then we're gonna set up our block and transactions, right? So we want to now create two collections, one for block and one for transactions. Of course, the blocks inhabited transactions. We can even set up some indices to make like the querying fast and everything. And it's very simple. We clear the two collections and we just say, well, listen, for every raw data entry, please parse the JSON that we are querying, parse it into a block, and save it. That's it. We run it. Takes a couple seconds. Then you can see that in MongoDB, there we go. There's this new Moonbeam collection with the blocks. Right? They now look very familiar. We don't see any other like Airbyte data in here. And the transactions are now, right, object IDs. Meaning now the transactions here are actually a reference to this newly created transaction collection, in which you now see here, we have the raw transaction data. What you could also do on the transformation script is whatever you want. You can turn the timestamp into a date format to make querying easier. You can prune fields. You can do whatever you want. And basically that's the main part. Now the ETL pipeline is done. So I thought for this demo purpose, what's very nice, I'm going to use a tool called Retool. People familiar with Retool? Quickly, hands up, hands down. Just one person, not many. All right. Retool is a no-code UI building tool, I guess. That is basically, you can just drag and drop like different UI things, and you can connect them to your database. So Retool is connected to our Airbyte MongoDB here. I created a very simple address field where you just enter an address, and then we execute this query right here, which says, well, please find me all transactions from this input field's value. And then we're gonna just display it in this table, where we see the data of this table is transaction from address query.data. That's it. If we click on preview and choose one of our from addresses from a transaction, paste it. There you go, right? We now queried the database successfully. We basically build our own index in 10 minutes, right? And what you can do now on top of this MongoDB database, it's completely up to you. We can, of course, now we can search by block number. We can do whatever we want. But I just really kind of wanted to make the point here that once the data is in your favorite tech stack, you just have suddenly unlimited possibilities working with that, right? And this is what this new tool from KYVE allows you on that. So that was the demo. I'm very happy everything worked well. The code will be available on GitHub, so you can play around with that. You can set up your own things. We'll probably create some initiatives around there, like a hackathon or something, to use this in your application. If you're a node runner, I would love to see this being used in your kind of like node syncing process, as we do have a full archive of a lot of blockchains. We'll be very curious also chatting with you guys later here, kind of like see how you would imagine this tool being used in your specific use case. Maybe quickly also talking about what's coming up next for KYVE. So we started in early 2021 where we had our first integrations, a testnet release. The incentivized testnet was very, very exciting for us. We had like around 40,000 participants there. We actually just released our new tokenomics and token mechanics because we did the switch to the Cosmos SDK for logic. As Jakub said, we were using SmartWeave in the early days. Unfortunately, outscaled that system a bit, so now we went to using our Cosmos SDK chain. We're doing the code freeze in a week or two, so that's very exciting. Getting the audit in place and then aim for mainnet launch by the end of this year. So things are getting very, very exciting for the team, and yeah, it's just an amazing experience for everyone so far. If you want to further connect with us on social media, we cover everything from Medium to Telegram. Feel free to check out. This way you will see all the updates. And yeah, thank you so much. I hope you guys all enjoyed the demo and the little talk about KYVE.